Hey, what's going on, guys? Let's do this problem right here. The first question is asking a restoring force of magnitude F acts on a system with a displacement of magnitude x. In which of the following cases will the system undergo simple harmonic motion? Now, in this case, we have to remember that for a spring system, F is given by kx, right? F is equal to kx. So this is Hooke's law, and from this one you can realize that F is directly proportional to x, right? Now let's look at the answers. The first one is not correct because that is root x square is not correct, this one is correct, sin x is not correct, and then 1 over x, that's also not correct. So this is going to be our answer. Now let's look at the second question. Second question is asking which of the following graphs describe simple periodic motion with amplitude 2 cm and angular frequency 2 radians per second. Now amplitude 2 cm, right? Now let's look at the amplitudes. For this one it's 1 cm, right? So this is not going to come. This is 2 cm, this is also 2 cm, this is also 2 cm, and this is 1 cm. So this is also not going to come, right? Amplitude is basically the height of this wave, right? So that's 1 cm, so this is not going to come. Now let's look at the second part. Also they are saying angular frequency 2 radians per second. Now to do this we have to know angular frequency equation. We know that angular frequency is omega, it's equivalent to 2 phi f, or another equation is 2 phi over t, right? So t is period, f is frequency. In this case the second equation is good because we have the time and this height, right? So now here we need the time for the second equation. Period is basically how long it will take for a wave to travel full wave. So in this case let's look at the second one, because we don't have to look at the first one because we already know the amplitude is not 2, so we already eliminated that. Now let's look at these three things and compare this 2 radians per second answer. So here the wavelength is going to be, period is going to be, let's start from this one to this one, right? One full wave. 2 to 4, it takes 2 seconds to travel one full wavelength. So that's going to be the period for this one. Now let's apply that one into this equation. Omega is equal to 2 phi over 2 seconds. And if you notice, if we get this one, we get phi. Phi is basically around 3 point something, right? So this is not equivalent to 2. So this one doesn't come. Now let's look at the next one. Starting from here, full wavelength, it's like almost 3 point something, right? It matches with phi's number. Now let's do the same equation, 2 phi over t. Now instead of t, I plug 3 point something, right? That's equivalent to phi, almost equivalent to phi. So we can cancel with phi, we get 2. So this one matches. Now let's look at the third one. So this is half of the wavelength, and that is 3 to 9, almost 6 seconds. Therefore full wavelength is going to be around 12. Now full wave period is going to be 12. So if we put this one into this equation, this is going to be 2 phi over 12, that's going to be equivalent to phi over 6. Phi over 6 means like half or something. So this is also not matching. So the answer for this question is going to be the second one, right? And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.